Peterson. Can you hear us?
Yeah, I can hear you.
Perfect. How are you today?
Good. How are y'all?
We're well. Thank you so much for taking the time to meet with us. We really appreciate it, and it is so inspiring to meet with you.
Oh, likewise, equally inspired.
Thank you. So, I would love to just jump into questions if that's okay with you.
Yeah, let's do it.
Perfect. So, I would love it if you could introduce yourself and give some background as to what your role entails.
Okay. Um, I'm Carrie Peterson. I'm an associate professor of biomedical engineering at Virginia Commonwealth University. In high school, I was decently good at science and math. I honestly wasn't quite sure at what I was going to do, but my parents encouraged me to go into engineering, and my dad was an engineer. So I was like, sure. I mean, you never know what you're going to get into, right?
Yes.
It seemed like a useful major, something I could get a job with. So I was like, okay, let's test this out. And college was pretty challenging for me. I did fail my first exam, but then I figured out how to study.
Oh, that's good.
I had not apparently learned that in high school. Um, and then I majored in mechanical engineering in college. I went to University of Michigan. I'm from Michigan originally.
Oh,
Yeah, and it was a great experience. I had a lot of fun in college and also like worked pretty hard, to be honest. But it seemed worthwhile. I got a scholarship that ultimately was important because I had to maintain a certain GPA to maintain that scholarship. And that was motivating. I was pretty terrified of like what would happen. Um, and then luckily I had some guidance from a sibling about graduate school. So honestly, otherwise if it weren't for my older two sisters, who knows what I would have come up with, but both of them had ideas of graduate school and gave me the rundown of how it works. Like, so your options are master's or PhD. And um, they explained to me the financial situation of that. So I don't know if you guys are aware, but if you pursue a PhD in engineering, that is funded. Like you get a stipend and they pay your tuition.
interesting.
Versus, yeah, this is important to know, right?
Yes.
Finances are important.
Mhm.
Um, so that was a factor. I was like, well, honestly, it sounds like then if I know I want to go to grad school, like a master's sounds like an expensive in-between option.
Mhm.
So I decided to go for it and applied to PhD programs. I did have an internship as well during undergrad where I was able to like make some money. So before I went to grad school, I took a year off and just traveled around Thailand.
Oh,
Yeah, so that was really fun. I wasn't just traveling, I was teaching English. And that was important too. Like Thailand's like very affordable. So I wasn't losing nor gaining money for a year, which was fine by me. I was having a great experience. Knowing that I was coming back, I had, applied to grad schools before I left. And then I went to the University of Texas at Austin for grad school, and I loved it. So that was good news. Really enjoyed research. So after that, I was like, just give me more. So I went on and did a postdoc at Northwestern University. And then things got real because it's like you got to get a full, an actual job in this field at some point. And and then luckily when I applied for faculty positions, I had success, which doesn't always happen. It's pretty competitive.
oh,
Um, and then I've been at VCU for 8 years now, and I like it a lot.
nice. That's so great to hear.
Yeah, after all that, right? It'd be sad if I didn't like it.
That's such a cool experience and like a journey you've been through from, starting in like high school and college and your trip in Thailand must have been very fun. And so that's
Yeah.
cool.
I will say also noteworthy because I think finances are important. Also, during my postdoc, I got a um, loan repayment program through the NIH, which
Mhm.
has helped. Like, it's a long journey, and the National Institutes of Health knows that. So they have this program for most postdocs and like early career people are eligible. Well, they will pay back your student loans.
Oh, wow.
Yeah, so there's resources to help you if you want this like decently long journey, knowing that like you're not losing money along the way, but you're certainly not gaining a lot. And you're like spending most of your 20s doing this, where, some people are actually making money.
Yes, finances are so important to like hear about, especially because like college is just so expensive sometimes. So it's really great that you provided insight as to like finances. We definitely didn't know like your PhD was pretty much like paid for if you actually pursue it in engineering. So that's like really, really interesting to know.
Yes, that should be more common knowledge than it is.
Yes.
That VCU and pretty much all schools, like we don't accept students unless we can fully fund them for 4 to 5 years, which it takes to complete a PhD. So, um, yeah, I do think it was a great journey. And that was kind of my mindset the whole way through is like, no matter what happens, like I'm having fun right now. So if ultimately I go work for industry and say maybe even my PhD and postdoc experiences weren't needed in the long run, like it didn't necessarily matter to me because like the whole journey was enjoyable.
Yes,
So
that's very important.
I
Yeah.
wish the same for everybody else.
Definitely, definitely. And so I know you mentioned, I think on LinkedIn, your LinkedIn profile, that you do a lot of research in biomedical engineering. So I was wondering if you could also share a little bit more about what type of research you do, because like research is very close to our hearts.
Okay. Yeah, so I didn't talk about what I actually do now. You get the gist that I teach classes, which is always enjoyable.
Yeah.
Um, and then research is more where you get the highs and the lows because it is so the type of research I do is related to rehabilitation.
Oh,
So after somebody has a neurological disorder, um, most of my focus has been spinal cord injury or stroke, so injuries to the nervous system, and then providing rehab options for them.
oh,
But
nice.
yeah, so more specifically, current projects are related to non-invasive brain stimulation and then like the biomechanics of wheelchair propulsion and understanding forces in the shoulder and how we can reduce those so people don't develop shoulder pain,
Hmm.
things like that. Um, so yeah, I'd say about at least 50% of my job is doing research. And as a lab director, what that actually means is I'm responsible for getting funding for my lab, which is like writing grants and stuff.
Oh,
Which I then use that money to pay for my PhD students who needed stipends and tuition paid for, and supplies and things like that. And then I largely manage the projects that they're working on, like be a mentor for them in their successful completion of their PhD. So yeah, it is a lot of fun. I wish I got to spend a little more time in the lab myself personally, but it's really more of a management role at this point. Along the entire journey, you're the doer. And then eventually, when you're a professor, you become more of like the manager.
oh, interesting. Yeah, and that management role is very important because I know labs can sometimes be very hectic and stuff. And so definitely managing a whole group of people who are doing research, especially research as important and interesting as yours, is very important.
Yeah, it's just like mentoring others. I obviously got a lot of mentoring along the way. And then now I'm the mentor.
And so I had another question for you. And so if someone wanted to pursue your footsteps and your path and, like get into research related to biomedical engineering and like that type of research, what advice do you have for that, like for that type of person?
Okay, well, I would advise them to major in biomedical engineering. Um, and then that's really where you get your foot in the door. Because, I mean, we have a lot of undergraduate students that work in our labs. So they're getting active research. Um, and that's a great way to figure out whether you like it or not. Yeah, at VCU, at least 90% of our students do undergraduate research while they're here.
Mhm.
Yeah, we're really proud of that. It's kind of like something that makes us stand out because it can be a little more difficult at other universities to like even get in a research lab. But
Right.
we're kind of like, there's a whole gamut. Some undergraduate researchers like publish, go to conferences. I would say the majority do those things. And then honestly, some people are kind of there for the hang. And like there's a world where that's okay too. Like we're also encouraging of like providing a nice college experience for people. So if it's more of a social hang, they're welcome. They're potentially not gonna get to go to a conference and like the some of the perks of the people who are a little more productive, but um, we're understanding like there's a range of how involved people want to be.
Yes, I think research as an undergrad and just in any stage of life is so beautiful because you learn about all like the opportunities, but also how to bounce back from failure because I know research is full of failure. Definitely.
Yeah, so I'm curious, what kind of failures do you think exist? I mean, I know, I just want to hear from your perspective.
Yeah, recently I've been like do conducting research regarding chemistry, and
Okay,
it's definitely a lot of human errors is involved, especially with micropipetting for me.
okay.
I was like, I feel like understanding the concepts might also have a little bit of gaps, especially whenever you don't really understand the fundamentals, which is
Hmm.
I cover that at school right now.
Yeah, okay. So that's one of them is like actual failed experiments.
Yeah.
That's one type of failure. Um, Other types of failure are you do the experiment right, like things go well. You're like, cool, we're gonna publish this. You put a lot of work into writing it up nicely and you submit it to a journal, and then the reviewers say, no,
Oh.
that's another type of failure. Um, because they might think there's too many limitations to what you did or whatever. But at least that's a little in your control. Like, and then also funding is rather competitive. So there's so many, that's the thing, like there's so many good ideas out there. And what gets funded is like what happens to be the most important at this current state. So it's not that all the other ideas are bad. It's just that we only can fund about 10% of these. Um, so yeah, there can be, that's why I'm talking about the ups and downs.
Very important for people to hear.
Yeah.
Yeah, before diving into research, I was like, oh, just make a project, it will work. And then it was definitely a learning experience for me the first year.
Yeah. Well, certainly in high school, I think that's the right idea is, you know, doing some experiments. And then further on, you start to understand what is really important is the why are you doing this?
Yeah.
Like, how is this important? And it can't just be because no one's done it before. It's got to be like an actual significant need that's going to help humanity.
Mhm. Yes.
I
Yeah.
know that's heavy.
And another question I have, this is like kind of a follow-up question.
Okay.
I was wondering, so because as you mentioned, research is so vast, it has its ups and its downs. And so I was wondering, how do you balance research with like, like outside work as well as like teaching?
That is the hardest part, I'd say, about this job is the juggling of, because I like it, like the diversity of tasks is really fun. Teaching is way different than doing research, honestly. Um, I at least teach classes that are very much related to my research, but it's just a different skill set.
Mhm.
And then like we do a lot of administrative things like keep the department running smoothly, stuff like that. So I just try and appreciate the different flavors that this job entails and try not to get too overwhelmed by like just the amount of stuff. And then setting boundaries can be good, just realizing that there the good news is like everything is stuff I want to do. The only problem is just the pure amount and like the juggling.
Mhm.
So just appreciate that nothing is too terrible. It's just you have to say no to some things that you even would like to do sometimes. So I
It's
I
true.
think I largely see it as a good problem versus there are other jobs, I know other adults who just largely don't want to do anything related to their job. And that would be a much worse situation.
Definitely. Right.
So at the end of the day, when things are, up and down, I'm like, try and see the positive, and that's pretty easy for me to do because I do like my job. So
Yeah, I'm glad you enjoy your job. I know how difficult it would probably be for people who don't like their job. So it's really cool how you view these different things as positive to your journey and stuff, and it's something you enjoy to do. So that's
yeah,
really very inspiring.
good. Yeah.
Yeah, and another question I had, this is more regarding your research. I think you mentioned how you work also on non-invasive brain stimulation. Did I get that
Mhm.
right?
Yes.
So I'm wondering if that's specific to the transcranial magnetic stimulation or if that's another aspect of neurology that I'm unfamiliar with.
No, we pretty much do transcranial magnetic stimulation in my lab currently.
Wow.
Um, it's a non-invasive way of stimulating neurons in the brain.
Hmm.
Um, I'd say the summary of where the field is at is we know it's useful, and we're largely figuring out exactly when it's useful, who it's useful for. There's still a fair amount of work to be done to learn more about, dosing, um, based on injury and disability, things like that. So I see that being so TMS was invented in the 80s, which might sound like a while ago to you, but to me, I'm like, it's still, you know, that's actually not that long ago,
Oh, wow.
in my opinion. Yeah.
And so does your lab use TMS mostly to treat depression, or are there other like ways that TMS can help? Specifically, like I know your lab mostly works with neuromuscular conditions and everything.
hmm That's a good question. So TMS was first developed and approved by the Food and Drug Administration to treat depression, but um, you can stimulate neurons in the brain almost anywhere. And so we target the motor cortex and
Uh,
we use it to like learn about the injury. So diagnostic capabilities as well as applied repetitively, it can cause changes in cortical neurons. And so we largely apply it in both diagnostic and rehab for motor function by
uh,
applying over the motor cortex.
that's so interesting. And this is so relevant to my life right now because in psychology class we just learned about TMS and the motor cortex, so I'm actually understanding what you're saying.
Okay, cool. Well,
Right.
even for depression, they first target the motor cortex because you can get a readout from a muscle there. So, like, depression is tricky, right? When you're targeting the motor cortex, you put a sensor on the hand You apply stimulation here, and you can actually measure with a sensor, like what is the signal to the hand,
Oh, wow.
right? So the motor cortex is a little easier in that sense because you get a quantitative measure. And even for depression, they first kind of get that resting motor threshold from the motor cortex. And then they extrapolate that to figure out, like, okay, what level of stimulation is needed then in the areas to treat depression.
Interesting.
Yeah.
Yeah, it's so cool how everything is like controlled in your brain. It's so vast and it's so impressive to me.
The brain is important.
Yes.
Wear a helmet.
And another question is, I know that your lab also does things on, I think you mentioned like wheelchair and making sure it doesn't put too much pressure on the shoulder.
Yeah.
So I'm wondering if that's specific to you designing prosthetics or if you're actually trying to design kind of ways that your shoulder doesn't get too impacted or.
This is an excellent question because a lot of our work is, well, us and other places that study wheelchair biomechanics. Overall, the summary is yes, the forces are pretty large on the shoulder.
Mm.
There's a bunch of predictors of shoulder pain, like age, body weight, years of manual wheelchair use. There's a whole host of things that can predict whether you're going to develop shoulder pain. But largely, like, unfortunately, most manual wheelchair users develop shoulder pain eventually. So then
Ah.
the question is, like, how do we prevent that? And I would say most, um, one of the better options currently are exoskeletons that can redistribute forces in the upper limb.
Oh.
So if you've heard of like soft robotics and soft exoskeletons, you see them in the lower limb more commonly, but um, there's certainly upper limb exoskeletons that can redistribute forces, sort of like try and reduce forces at the shoulder. Might be a good option.
Oh, and what are soft body robotics?
What are they?
Yeah.
Largely just when you think of an exoskeleton, particularly in movies, right? They're rigid and hard, which for, let's say you have a spinal cord injury and you can't support your body weight, yeah, you're going to need something hefty and large, and that's a like hard exoskeleton.
Ah.
But if you're just need a little bit of assistance or you're wearing it somewhere where a hard device would be, pretty obtrusive,
Mhm.
soft exoskeletons refer to just honestly just like softer materials,
Ah.
not just like metal.
And that prevents like a lot of tension in the area. Is that what you said?
Well, soft robotics can be for like comfort, um, ability to put it on and take it off easier. Um, yeah, really just practical things like that.
Oh, that's cool. I definitely need to do more research about that.
Soft robotics.
Very interesting. And another question I had was, so I know that you were talking about your journey in the beginning, which is an amazing journey, by the way. And so I wanted to ask you, what is the most significant lesson that you learned from that journey? Or maybe you can talk about what was a challenge in your journey that led you to learn something very impactful in your life.
Um, well, luckily I didn't have any major failures.
That's
I
good.
don't know what that would look. I guess like a major failure is like, you know, in, going into graduate school. I mean, not everybody successfully completes their PhD. So I guess that could have been a place for failure, or maybe not actually getting a faculty position. Those things all worked out for me. So I guess I just had like minor setbacks. Like basically, you put years into research and then you submit to a journal, it might get rejected.
Mm.
Um, Same with like grant applications. You put months or maybe even a year into a grant application and it gets rejected. So those are the types of rejections I've dealt with. Uh, but I know that everybody experiences those. And so that's helpful to know. And also kind of just keep looking at the net effect. Like you're going to have, along with your wins, there's always going to be setbacks.
Mm,
Um, and so you just can't let the setbacks bother you. You just have to know that's part of the game and keep going.
That's definitely a great mindset to have.
I mean, that's just like life in general, right?
Yeah.
I will say, I mean, most people who are privileged, like, I hopefully you guys are in this camp, but seems like you are. Um, I would say throughout, going through high school, I don't know if I had any major setbacks. It's just like things kind of swim along. You're like, oh, life's pretty good. And then once you start doing harder things and getting outside of your comfort zone, that's when you start to experience setbacks. But the alternative is never trying something difficult. And so I would say just don't be afraid to try hard things, knowing that even if you do not make your ultimate goal, like if you aim high, you're only gonna like fall a little bit shorter.
Mhm.
So
Yes, that's definitely true. I need to definitely implement this to my school life as well.
yeah, just the higher you shoot is like really respectable and commendable for trying, I think.
Yes, I definitely agree that trying is somewhat more successful and important than where you actually land. That's
Yeah.
really very relatable and important to know, especially
Mhm.
for the community and everything.
Mhm. Yeah,
Yes,
everybody experiences setbacks.
yes, yes. That's like a very important thing to know about all people are actually human and they're not like robots and everything.
Yeah, it's normal. It's never fun, but it happens. And it's like, I mean, we all know like famous scientists make quotes about like the number of failed experiments to get like one that works. Like that is so true. Yeah.
And so my last question is, it's if you could meet with any person, past or present, who would it be and why?
Okay. And I did appreciate getting this one ahead of time. This one was probably the most difficult. But also I didn't like think about it too long. So I'm gonna have to say my great grandmother.
Oh,
And so it was nice. She lived to be 104.
oh wow.
Yeah. So I did know her. She is now passed. Um, but I'd like to, go back and talk to her when she was like my age, because I just think things have changed so much so quickly that
Yeah.
even though we're like related, we're both from Michigan, I think our lives have been extremely different. And so it would be kind of fun to like talk to her. I'm 43. I'd like to talk to 43-year-old Clara Talsma, and I think we would both be fascinated about like what our lives were like, separated by, oh gosh, I don't know how much older than like she's probably like 80 years older than me,
Oh,
right? I think but 80 years in the scheme of things is not that long, yet I think we've lived incredibly different lives.
yeah,
That's my answer.
that's
Do you
so
guys have an answer for that one?
we haven't really thought about it, honestly. I mean, yes, I would love to like probably meet with like Rosalind Franklin or Marie Curie. They're very inspirational to me, but I definitely am very inspired by your family story. That's really nice.
Yeah, I mean, those are great choices too, because it'd be the same flavor of like, this is what women can achieve in 2024.
Yeah,
What was it like in your day?
yes,
Probably not as, they would probably be more fascinated, honestly, by the conversation than us. We'd be appalled
yes.
and they'd be like, what?
Yes, it's always so interesting to know what people in the past would probably say about the present and vice versa. I'm always
Yeah.
very curious about this.
Hmm.
Yes. And I was amazed whenever my biology teacher, she was talking about Rosalind Franklin and all of the challenges she had to go through as being a woman who was trying to revolutionize genetics and our understanding of DNA structure. But she definitely made an amazing impact on the world and everything.
Yeah.
She's just amazing.
I know. Talk to her about her ups and downs.
Yes.
Whew. I'm sure she would have a lot to say.
Yes.
It's so I can speak to, I think it's gotten a lot better for women in science and engineering. Yeah, I've had a lot of, I don't have any sad stories there about, I've only experienced like really positive mentors.
That's good.
Yeah. I mean, I'm sure there's other people my age who wouldn't say the same thing, but in my experience, it's all been great. And so I appreciate that.
That's awesome. Yeah. And did you have any specific mentors that really helped you around your journey?
There's like several. Um, so my in undergrad, I had a PhD student who is now a professor at University of Colorado Boulder. She
Oh.
was amazing. She basically got me into biomechanics and encouraged me to go to grad school. And then my advisor in grad school, he was outstanding. We're having a reunion this summer with like, I graduated from grad school 14 years ago, but we're all getting together in a social aspect this summer. So it's like kind of you get family ties from academia. Then my postdoc advisor, she was outstanding. And I still keep in touch with her. Dr. Murray at Northwestern. Dr. Neptune was at University of Texas for grad school. And then I still currently have mentors. Like there's always people more senior than you. Um, so yeah, I think I got lucky to get myself involved with some really outstanding people.
That's amazing. Yes, mentors, they always provide guidance and support. So it's always nice to have someone who's there for you, who's been in your
Yeah.
shoes before. So,
And that's probably why I like my job so much is because those people like their jobs and like it just makes a nice environment.
yes. Yeah, well, those are all of my questions. Do you have any? No, yes, you've answered all of my questions perfectly, and I loved hearing about, your story and what you do. So it's really interesting to meet you. Yeah.
Yeah, nice to meet you too. Thank you for the opportunity. It seems like you guys have the right optimistic mindset to be
Thank
successful.
thank
That's needed. So,
We
best of luck
appreciate
and
you.
keep in touch if you'd like.
Yes, definitely. We would love to keep in touch, talk more about your research sometime, and definitely just stay connected to like such a role model in the field.
Yeah, happy to help if I can.
Well, thank you so much. And again, we appreciate your time and effort.
Yep.
Yes,
Thank you. I appreciate your time too.
Have a good day.
You
Bye.
too. Bye.